Assalamualaikum everyone. Today we're going to cover a new topic which is welding. There are 6 parts of welding that we're going to cover in this topic. So here are some topic that we're going to cover today. There will be 5 topics. Among them are overview of welding technology, weld joint, power density, heat transfer, and also heat affected zone. In manufacturing process, there are 2 types of process where we can join or we can assemble the parts together. So the name will be joining and assembly. So for joining, the example of the process is like welding, brazing, soldering, and adhesive bonding. So this process form a permanent joint between the parts, meaning there is coalescence between the part of the final product. As for the assembly, it is a mechanical methods usually for using the fastening part. Okay, so for example, you use a bolt and nut to assemble the part together, and some of this method will allow for easy disassembly, while some of them and do not give any uh, methods for the disassembly. Welding can be defined as a joining process where 2 or more parts will be coalesced together at their contacting surface by application of heat and pressure. Some of the welding process accomplished by heat alone and no pressure applied. Another, there will be combination of heat and pressure. Um, Still other also involve pressure alone and no external heat. In some welding process, a filler material also should be added to facilitate coalescence. There are some reasons why welding is important. Firstly, it is a permanent joint, so it provides a permanent joint where a welded component will become a single entity. So this process also economical. So in terms of the material usage and fabrication cost, it is considered cheap compared to the mechanical fastening. So for mechanical fastening, it requires additional hardware, for example, screw, nuts, and bolt, and geometrical alteration of the assembled part are also needed. For example, the holes you will need to do the threading and many other processes. So for another thing is there is no area restriction, so no restricted to the factory environment. You can perform the welding process in many area, and even welding can be accomplished in the field, meaning that you can perform it anywhere where it's supposed to be assembled. Despite that, there are also limitations and drawbacks of welding. For example, it has to be performed manually, and the cost, you have to bear the cost for the labor. So it also utilizes high energy and inherently dangerous, and it do not allow for convenient disassembly. If there is mistake in the welding process, you have to remove everything, and then you have to rework the material again, since it is not convenient to disassemble. And then the quality defect that are difficult to detect, and sometimes uh, there are small hole or some shrinkage inside the welding part. We are not able to detect it unless we have to perform various testing. So let's see the fairing surface in welding. Fairing surface is the part where the surface is contact or close proximity that are to be joined. For example, if you can see here, this is there are 2 plates. So this part will be will be placed together. So this area that we want to join together is called fairing surface. So welding usually is performed on this area. Okay, so the place where the material contact to each other is called fairing surface. Welding usually involve the localized coalescence of the 2 metallic part, where they are faying surface. Okay, so meaning that when the material contact to each other and there's faying surface, and then we're going to join it together. So welding is usually performed on part of the same metal. Okay, so for example, you're using stainless steel, so both side is stainless steel, but there are also some welding operation that is specialized on joining the dissimilar metal, and also you can also perform different material, for example ceramic and also metal, not only metal and metal. There are more than 50 different types of welding process that have been catalogued by the American Welding Society. These welding processes can be divided into two major categories, which are fusion welding and also solid state welding. Fusion welding is a joining process where the base metal will be melted. Okay, in many fusion welding, usually filler metal will be used, where it added to the molten pool to facilitate the process, so that the bond between the weld bit is stronger. So a fusion welding operation with no filler is called autogenous weld. The major fusion welding processes are there are arc welding, resistant welding, and also oxy-fuel gas welding. This is the main fusion welding. Under this process, there are a lot more processes. So we are going to look into these three type of fusion welding. Okay, so for arc welding, melting of the metal is accomplished by the electric arc. Resistant welding, melting is accomplished by heat from the resistance from electrical current between faying surface held together under pressure. And oxy-fuel gas welding, which is melting is accomplished by oxy-fuel gas such as acetylene. The first one showing here is the arc welding. So in the arc welding, there will be filler metal, and then there are also if you can see here, there's electrode. Okay, so and then there are also supply of electric here, so this one is used to melt the filler. Okay, so next one is oxy-fuel gas welding. So if you can remember in the workshop process, so this one is the gas supplied, acetylene and oxygen usually used, two type of gas. And then there will be filler rod that can be used to fill in the welding part. Okay, and this is the third one is resistant welding. So the resistant welding is using the AC power supply. So here is the faying surface, and then we supply the pressure over here, and also heat will come here. So then there will be a nuggets of weld on the surface, the faying surface. The next process is solid state welding. So joining process, solid state welding is a joining process in which coalescence results from the application of pressure alone or combination of heat and pressure. Okay, so if heat is used, the temperature is below the melting point, so meaning that the part that we want to join will not melt. Okay, so no filler metal is added in the solid state welding. There are three major solid state welding process that we are going to cover in this class. So they are diffusion welding, friction welding, and ultrasonic welding. So diffusion welding is a welding process where two surfaces are held together under pressure, and then temperature is elevated, and the part will coalesce by solid state diffusion. So meaning that the metal from these two layers will be diffused into each other. The next one is friction welding. So friction welding coalescence is achieved by heat and friction between two surfaces. So we're going to look in detail on this one later. And the last one is ultrasonic welding. So this one is there are moderate pressure applied between the two parts, and then there will be oscillating motion of ultrasonic frequencies is used to weld the parts together. So this one is usually used for joining the wire. Okay, so for electrical parts. Okay, so the combination of normal and vibratory force between this part will result in the shear stress, so that it will remove surface film and achieve atomic bonding of the surfaces. In here, these are the schematic diagram for diffusion welding, friction welding, and also ultrasonic welding. We're going to look in detail later in next lecture. Now, let us look into the weld joint first. Okay, so the junction of the edge or surface of the part that have been joined by the welding is called weld joint. Okay, so there are two issues that you have to know about the weld joint, which are the type of joint and also type of weld used to join the pieces that form the joint. Okay. First, let us look the 5 type of joint. Okay, so if you can see the picture here, A is butt joint. So if you can see, this is named based on the appearance of the joint itself. So if you can see here, no, it's funny, but then it is easier for you to understand. If you can look into this one, so this is called butt joint because it looked like a butt. Okay, and then we have corner joint because there are corner here, the joint will be performed at the corner here. And then we have lap joint. It is like a lap, like people sitting on the lap, right? So that's why it's called lap joint. And then T joint because the shape is like T joint, like T. And then they have edge joint. So this is where the place the joint will happen. Okay, the weld will happen. Now let us look on the type of weld used to join the piece that form the joint. Okay, the first one is fillet weld. So fillet weld is used like this. If you can see, this is for corner joint. It can also use for the corner joint also here. So this one is corner joint, this one is also corner joint. Okay, so this one is inside corner, this is outside corner, right? So it can also use for lap joint, and it can also use for T joint. So the next one is groove weld. So groove weld can be used for butt joint. Okay, so it can also form into certain shape that we call V groove weld. It can also be a U groove weld, and also it can be J groove weld, and it can also be double V groove. Okay, so these are the type for the groove weld. So this one is plug weld and also slot weld. So plug welds usually used for the lap type of joint, but in here there will be hole that need to be created. So then the filler will be put inside the hole, so that they will be joining between the two fairing surface. Okay, this one slot weld, meaning that you have to create the slot and then fill in the filler inside here, so that these two lap fairing surface lap joint can be joined together. The next one is spot weld and seam weld. So spot weld meaning that if let's say you have one lap joint, so instead of filling all the way here, you just put some spot of the filler to join the part. Okay, so this is a spot weld. And for the seam one, it is a continuous one. Okay, so then it create a line of weld along the way the lap joint. So the next one is flange weld. So this one is made for the edge of the two parts. So this one is usually for the edge joining. Okay, and then next one is surfacing weld. So instead of joining the part, it is rather to deposit the filler metal into the area. Okay, so on the surface of the base part. So that's the end for the welding part 1. We'll see you in part 2.